AI incidents vary widely. A biased output, model failure, or security threat each calls for a different response. In this section, we'll turn risk signals into severity ratings, escalation paths, and practical response priorities. We've built the foundation: how AI changes the enterprise, how governance creates accountability, and how AI risks emerge. Now we'll apply that knowledge operationally by classifying incidents, setting priorities, escalating quickly, and learning through review. AI incidents go beyond system outages or data breaches. They can involve harmful outputs, unfair decisions, unintended autonomous behavior, or performance drift. Classification gives teams a shared language under pressure, helping them judge impact, meet compliance duties, identify root causes, and prioritize the failures that matter most. An AI incident is broader than a model making a mistake. It is any AI-related event that causes harm, or comes close enough that intervention is required. The source might be a bad output, exposed data, a prompt attack, a failed approval process, a vendor model, or autonomous action. The key distinction is impact. A defect is a flaw. A risk is potential. A policy violation breaks rules. An incident is when harm, exposure, or a near miss enters operations. Because AI failures take different forms, categories matter. Hallucination harm occurs when false output creates real business, legal, medical, financial, or safety impact. Sensitive data leakage means confidential or regulated information is exposed. Prompt injection is an attacker steering the model, retrieval, tools, or workflow through malicious instructions. Unauthorized agent action happens when an AI system acts beyond approved authority. These categories help teams root ownership, investigate root causes, and understand compliance obligations quickly. Enterprise AI incidents can also emerge outside the obvious cases of hacks, leaks, or prompt abuse. An incident might be an unfair decision pattern, a model that quietly degrades as conditions change, a use case that violates regulation or policy, or a dependency failure from an outside model provider. A useful mental model is origin and impact. Some failures are technical, others are governance-driven. Some are immediate, others emerge slowly. Incident management has to detect and respond across all four. A taxonomy turns a vague AI incident into a rootable case. First, name what happened: leakage, hallucination harm, bias, injection, drift, or outage. Then identify where it happened: model, prompt, agent, data pipeline, RAG store, API, or provider. Next, define the impact domain and severity. That combination determines who leads the response, whether SOC, privacy, legal, model owners, or executives. The goal is consistency, so every team reports and escalates the same way. Once an AI incident is classified, risk scoring turns it into a response priority. Don't score only the technical failure. Consider how critical the affected business process is, how many users rely on it, and whether the AI can act autonomously. Then weigh the sensitivity of exposed data, regulatory duties, explainability needs, and how hard recovery will be. High-risk amplifiers, such as regulated data or irreversible actions, should increase urgency even when the initial symptom looks small. Severity models turn messy incident details into consistent action. For AI, the usual P1 through P4 scale needs extra lenses. A critical incident is not just downtime. It may involve biased decisions at scale, sensitive data exposure, unsafe autonomous action, or a regulatory breach. Lower levels reflect how contained, explainable, and recoverable the issue is. The key is to define thresholds before incidents happen, so teams can escalate quickly, apply the right response time, and avoid debating priority during a crisis. Prioritization asks more than how bad was it. It also asks, how likely is it to happen again, and how fast can it spread? A rare but severe legal or safety issue still deserves strong mitigation. A frequent low-impact issue may reveal a deeper governance weakness. For AI, raise urgency when automation can propagate the problem. Many users can be affected, or outputs influence high-stakes decisions. The goal is to match the response level to real operational risk. AI incident response needs clear decision rights before pressure hits. Each incident category should have a primary owner, with secondary owners ready to support across technical, legal, privacy, compliance, business, and ethics concerns. The owner must know which decisions they can make, such as containment, rollback, notification, reporting, or service suspension. Escalation thresholds then define when to involve legal, the CISO, risk, governance, or executives. This prevents delays, duplicated work, and accountability gaps. Playbooks make AI incidents manageable by turning judgment into a repeatable sequence. Start by detecting the specific failure mode, then classify and score severity. Containment should be concrete. Disable risky tools, roll back a model, block prompts, isolate retrieval sources, or switch providers. At the same time, preserve evidence, logs, and decisions. Recovery is not complete until communications, legal or customer obligations, risk acceptance, and control improvements have been reviewed and tested. Incident records should become a shared source of truth. Security teams use them for alerts, containment, investigation, and threat response. GRC teams use them for risk issues, control mapping, regulatory reporting, and evidence. Model registries add the version, data, prompts, owners, and deployment context. When these workflows are connected, AI risk stops being scattered across teams and becomes traceable, auditable, and actionable. An AI incident is not closed when service is restored. It is closed when the organization has learned from it. The review should trace root causes across the model: data, prompts, access, agent permissions, vendors, and human oversight. Then convert findings into stronger policies, playbooks, evaluations, monitoring thresholds, and approval gates. Recurring incidents should be escalated as governance signals, so risk committees, security leaders, AI oversight teams, and business owners can correct systemic weaknesses. The key is to turn AI risk into repeatable operations. Classify incidents in AI-specific terms, score them by impact, sensitivity, autonomy, and regulation, then escalate through owners, playbooks, and SOC GRC workflows. Use every review to improve governance. Next, we build secure AI architecture, including LLM, RAG, and prompt security foundations.